Hi, my name is Reinaldo Vargas, and I'm going to talk to you about the new checklist of Chilean lichens, uh, and mostly about the distributional patterns of the richness of the lichens present in Chile. So just to get an introduction, and if we think about the potential numbers of Chilean lichens, in 1988, David Galloway and Juan Aguilar published the checklist of Chilean lichens with roughly 1,400 species in 281 genera. But previous to that, Gertrude Coleman proposed a number of around 2,500 species present in the country based on his efforts to build a checklist during the 60s and the 70s for the country. But this was based mostly on an observation due to his experience working in the country and in his ongoing work to describe the diversity of lichens in central Chile and in northern Chile. In an effort to update this checklist from Galloway, in 2020, we published in GBIF a preliminary checklist of the lichens of the country with over 2,100 species in 464 genera. At the moment, we assume that we are around the 80% of completion of this work, and in the total number of known species published to date in the country. And working on this checklist, we build a database of records from different sources, and we include in this database and we clean in this database mostly species that we can give some distributional information, namely latitude and longitude. And that reduced the number of species in this database to 928. So if we use these to build a rarefaction curve to assess the number of species that potentially can be found in the country, we can see that projections based in a duplication of the amount of samples that we have studied so far gives a rough number of around 2,400 species potentially present in the country. So that gives us the idea that maybe Dr. Coleman was pretty spot on his prediction on the diversity of lichens in the country. But mostly now we are interested in the distributional patterns of the species based on this database that we built that has over 43,000 records with 2,276 species. If we clean this database with only the records that we have geographic location, is around 33,000, which is 78% of all the species that we had in the database. So it's highly reduced. And we built this database using information from different herbaria. Here, the list of the herbaria that I was able to get some of the information myself, but many of those as well, I got the information from online databases, mostly on the working effort of the consortium of the North American Lichen herbaria and other sources. So after cleanup of these records, we try to estimate how biased were there in relation to the position of the cities and the rivers and roads and airports, just to get an idea of how undersampled was the country. And here we can see that most of the locations that we know of, they have a bias towards the cities, which shows in the map and give us an idea that in areas where we have low sampling bias, these areas actually have accessibility issues. Mostly in the southern part of the country, most of these areas we can only visit by boat. And in the northern part of the countries, most of these areas are very difficult to get because they are really far away, and in many places there are no suitable roads or mapped roads that will allow us to get there easily. But we can see that although we have a large number of species and we have a roughly good completion of the checklist of the lichens on the country, this shows that there are still a lot of places that we haven't visited. There are still a lot of places that we need to check again to see if the richness is higher that we can find on the current databases. So if we build a grid of 0.5 degrees along the country, we can clump the numbers of species in each of these grids to get a rough estimate of the distribution of the richness. And if we see here, we can note that coastal northern Chile, central Chile, and the Mediterranean areas, and the Valdivian temperate rainforest has the higher richness, also here in the Lichens region and in Magallanes region, which is related, of course, in central Chile with accessibility, the Valdivian rainforest, because it's very special and unique, and it's a representation as well of a microclimate that it starts in this part of the country, and it's comparable to other microclimates that we can find in the northern hemisphere and in other parts of the southern hemisphere, like New Zealand. So we can see that the distribution mostly, the richness mostly concentrates in the central and the southern part of Chile, and also in the coastal northern part of Chile. But if we want to expand in some way to areas that we don't have much information, we can use a strategy that is the extent of occupation. And this is a strategy that is used by the IUCN to estimate the distribution and the occupation of the species when they are under evaluation. And it's basically the construction of a polygon using the known localities for each species, and then assume that in this whole polygon, the species can be present. If we do this for each species in the database, and then we sum the number of species on each of these squares in our grid, we get higher numbers of distribution and a little bit more smoothed out pattern. And it's a repetition of what we saw before, just a high number of species in the Valdivian temperate rainforest extended to the Aysén region and Magallanes, and also here in central Chile, extending to the coastal part of Chile, which is also in some views considered as Mediterranean in some ways. If we study this pattern of richness along a latitudinal gradient and following the regional level, that administration regional level, we can see that there is a pattern of increased richness from northern Chile to southern Chile, with a lot of places where we have very low richness that is due to undersampling, particularly here in central Chile. But we also see the Valparaiso region, which has over 600 species estimated for the whole region. But this is due mostly because associated with this region, there's the Juan Fernandez archipelago and Easter Island. So these two oceanic territories increase the number of species, because in Juan Fernandez we have a lot of temperate rainforest elements that are increasing the number of species that we will find normally in Mediterranean areas in continental Chile. And then in Magallanes region, we have this high diversity, which is given to the break between the temperate rainforest in the southern part of Chile and the beginning of the boreal or Antarctic biomes in the southern part of the country. In a latitudinal gradient view, we can see there is a positive correlation between richness and latitude. So as we move southwards, we have an increase in the species richness, and we have some odd points like minus 33 and minus 34 degrees. This is Valparaiso region as well, and it's also the effect of the Juan Fernandez archipelago and Easter Island. If we look at the endemicity, which is a proportion on the number of records that we have of a species and how close they are, we can see that coastal northern Chile has a high endemism index. which is something that we know about because of the special conditions that the lichen has in the northern Chile, mostly present in what we may call as lomas formation that are maintained mostly by the fog. In central Chile, we have another spot of high endemism, which is given to the transition from the northern part of the country and the desert into the Mediterranean areas of the country, this hotspot of biodiversity. And then the other endemicity area, or the area with high endemism, is in the southernmost part of the country with the beginning of the boreal microclimate in the southern part of the country. So this is not something new, of course, but it's interesting to see that we can retrieve this from the data that we have accumulated using different strategies. So to try to get a broader picture of the richness of the lichens in the southern, in the rest of the country, in the areas that we don't have information, we model the diversity using two different strategies. One of them is the creation of what is known as stack species distribution modeling. So for this, we build models for each of the species in the database using SDMs. So for this, we have different environmental layers and we have field observations. And we model these using different algorithms. In this case, we use a GLM, regression strategy, and GBM, a boosting method strategy, to assess and model basically the distribution of the species. So for stack species distribution modeling, we build these two models for each of the species in the database, and then we stack them to get the average. And we sum the number of species on each of the quadrants that we built in the previous steps. So the resolution is 0.6, 0.1 degrees, which is roughly between 0.5, it's roughly 5 to 6 minutes arc. Okay. And we remove all the species that have less than 5 records because those are not possible to be modeled. We reduce the number of species to roughly 1,600. We also projected the models to the future, to the range between 2081 and 2100, just to get a rough idea of the impact of the changes in variables that are related to temperature and precipitation on the distribution of lichens. And we selected a generalized circulation model, the GFDL, in two different socioeconomical conditions. One that is really mild, the SSP126, which assumed that we basically heavily reduce the production of CO2. And a not so mild, more on the harsh side, socio-strategic pathways that assume a small reduction on the emission of CO2 in the atmosphere. So we did this using stack species distribution modeling, but at the same time, we use an alternative that is macroecological modeling. And for this, for each of the quadrants that we build, this 0.5, this 0.1 degree, we count the number of species present. So to get just the richness number for that quadrant, and also we use the same variables at the same resolution, and we model the richness present in that quadrant instead of modeling the probability of presence of each of the species separately. So just to get these two different views to model the distribution of the richness in the area. So we compare our modeling, the macroecological modeling, or here as MEM, and the SSTM as the stack species distribution model. We compare them to the extent of occupation rate. So this is at 0.1 degrees, and we can see that macroecological modeling doesn't really show the same pattern that we can see in the EEO. but the SSDN shows more or less similar patterns with high richness in central Chile, which is rather similar to what we see in the EEO, and also in the temperate rainforest in the southern part of the country. So if we compare these, we can see that the macroecological modeling is somewhat correlated to the extent of occupation that we projected, but the case of the stack species distribution models, they are more close to what we are observing right now. So this kind of model seems to be better to fit the known distribution of the species versus what can be project in a model. But if we compare the macroecological models between the different models that we build between them, we can see that they are correlated, although the correlations are rather low. If we make the same comparison using the macroecological models and the stack species distribution model, we can see that they are correlated in the different future scenarios at different degree, but we can see that in a rather mild scenario for the future, their comparisons are rather similar to what we get in the current time. But if we move to a harsher scenario, we can see that the correlations are rather low. But still, they are correlated, so that gives us confidence that this is a good way to go to work on the estimation of the diversity and the richness of species, both currently and in the future. So if we check the current and future projections of the stack species distribution modeling for the scenarios that we model, we can also estimate the coefficient of variation, meaning how much a measure of the difference between the current and the future estimation. And we can see in the milder scenario that there is an increased number of species potentially in the northern part of Chile, mostly close to the Andes Cordillera, and an increase of number of species in central Chile moving from the Mediterranean areas to the temperate areas. If we see in a harsher conditions for the future, we can see that these numbers increase with a maximum of over 50% variation, mostly in the northern part of Chile, and also in the southern part of Chile, moving downwards towards the temperate rainforest. If we check the same comparison for the macroecological modeling, we see a similar pattern, an increase of number of species in the Andean areas of northern Chile, and a move southwards of the diversity towards the temperate rainforest, meaning a moving southwards of the whole Mediterranean richness to the temperate rainforest. But if we try to clean up these patterns and we estimate the species gain, the species loss, and the species turnover, we can see that the scenario in a harsh condition in the future, and this is only for the SSDN, which is more correlated with what we are seeing right now, it shows that there will be an increase of the number of species in the northern part of Chile, especially due to the change in the rain patterns. And so most of the rains that we get during the winters or in the summer in Bolivia and in Peru, in the Andes, will start to move eastwards towards Chile. So that would create conditions that might be beneficial for some species to colonize these new areas. But at the same time, this increase in temperatures will move downwards the diversity that we are seeing right now in the Mediterranean areas of the country, southwards towards the temperate rainforest. And at the same time, that diversity that we see in the temperate rainforest will move southward as well towards the southernmost tip of the country. And this is mostly due to the increase of temperatures and the reduction of the total precipitation. So in some parts, we will have a maximum of gain of around 111 species. But at the same time, we will start to lose species in different parts of the country, particularly in the coastal parts of the northern Chile, in central Chile, in the Mediterranean, and a move downwards from the temperate rainforest towards the southernmost tip of the country. So these give us an idea of the species turnover. So how many species are going to disappear in this future scenario and how many species will be gained. And we can see that in the northern part of the country, it's due to this new regime of water input, we will have an increase of species, and in other parts of the country, we will have mostly a reduction of the number of species due to change in the climate affected by different climate change scenarios. So I want to thank everybody for hearing this talk, all the herbarium credits that allowed me to use the information along the years. And especially I would like to thank the National Science Foundation associated with the Go Life project, which is led by From Solid Sunny and others. And I want to thank them also for allowing me the use of their cluster for all the analysis. Thank you.